Hello everyone, I am Sonali. In this part, we will learn non-comparison based sorting. Here we are not comparing the elements. Okay, these are the type of non-comparison based sorting. The types of this sorting is counting sort, Reduced sort, and bucket sort. We will say these two counting sort and reduced sort in our syllabus. Sorting without comparing the elements, rather by making certain assumptions about the data. They are called the non-comparison based sorting. First we will see counting sort. Here we are counting the elements. Okay. Sorting according to the keys. Here we are considering the keys inside the array. Counting the elements having a distinct key value. Let's see one example so we will understand this better. Here is the example. Okay. Here are the elements of our array 4, 2, 2, 8, 3, 3, 1. These are the different elements. Okay. See the algorithm for this. Counting sort. This is your array of size. Here is the size and here is your array. Okay. This is your array and size. How many elements? 3, 6, 7. Okay. So 7 elements inside our array. Max. Find the largest element in array. Okay, max is what? Find the largest element in array. So, which is the largest element in array? This is your largest element. So, scan for the largest element. So, we need to use the one loop to scan from 0th location to the n location, largest element. First, consider this element is the largest and then compare this element with this. Okay, here you will get the largest. Then compare this with this remaining element. But no any element greater than this. So set this element as a maximum. This is your largest element. Okay. Then initialize count array with all zeros. Next step is initialize count array with all zeros. See here, initialize the count array. Count array for what? See, initialize an array of length max plus 1. Here, what is the element 8? Okay. But we are starting the array from the 0. So assign this length plus 1. Okay, so length is 8. So 0 to 8. Total 9 elements we want. Okay, with all elements 0. So 0 to 8 means total 9 elements. Here we are assigning the value 0 to each element. Initialize count array with all 0. Okay, then for j, okay, j equals to 0 to size. Okay, see here. Store the count of each element at their respective index in a count array. Okay, this is a count array. Okay, here store the count of each element. Count of each element means suppose count of 0. Okay, count of 0. How many times 0 inside this given array? No. Compare this 0 with all these elements. Okay, 0 is here. No, 0 is not present in this array. So write the 0 here. Okay, this is our index number. This next line is index number and this is our count. Okay, then find for the 1. Okay, and then 1 is present in this. Yes, present only one time. Okay, so write the 1 here. Then for the second, okay, for the 2, find out the 2 is present. Yes, first time. This is second time. Again, search till the end of array. Okay, 2 times this 2 is present. So 2 times this 2 is present. For the 3, 3 is present. Yes, 3 is present 1 and 2. 2 times 3 is present. Search for the 4. 4 is present 1. Okay, only one time 4 is present. So write the 1 here. Then search for the 5. 5 is present. Search from this 0th position to the end of your array. No, 5 is not present. So write the 0. Then search for the 6. 6 is present. Compare with all the elements inside array. Okay, no, 6 is not present. So write the 0. Then for the 7. 7 is present inside this. No, 7 is not present. So write the 0. Then last element is 8. So for 8 is present. Yes, one time 8 is present. Now after this. So write the 1 here. Okay. This is store the count of each element at their respective index in a count array. We have written the count of each element. Okay, in a respective index. So go to the next step. Okay, or in algorithm, our next step is for add to maximum, find the cumulative sum and store it in a count array itself. Okay, so cumulative sum. So cumulative sum means for how many times one find 1. Okay, 2. Okay, cumulative sum is here. Okay, in previous, see, for the 1 there is a 1, for the 2 there is a 2. So cumulative sum is 2 plus 1 is 3. In this case 3 plus 2 is 5. Then 5 plus 1. Okay, in this way we will do the cumulative sum. Cumulative sum of 0, first here is a 0, then here is a 1. Then 1 plus 2 is a 3. Then 3 plus 1. Okay, in this way we will add the element of this array. See, we are adding this element. Means here is 1, 2 at the second place. Okay, second place here is a value 3. See, here is a value 3. Again check. Here is a value 3 plus 2. So here will be 5. So here is 5. Again here 5 plus 1 is 6. So in this array write the 6 here. Okay, then 6 plus 0 is 6. Okay, then again 6 plus 0 is 6. And at the end 6 plus 1 is 7. So here 6 plus 1 is 7. This is a cumulative array. And then our next step is find the index of each element of the original array in the counting array. This is our original array. Okay, find the index of each element. This is 4. Okay, find the index of each element, index of this element. Okay, in the original array, in the counting array, find the index of each element means the this is your original array. Original array here is 4, and this is your counting array. Okay, this count array is this. Okay, so match this 4 with this 4. Okay, we have calculated this also and this also. Okay, so this is the original. In original array, first element is 4. So match this 4 with the counting array with the index 4. 4 is here. Okay, what is the value at the location of 4? 6. Okay, so this gives the cumulative count. This will give the cumulative count of this. Okay, here we have written the cumulative count. Okay, here. So at the fourth position we have written the cumulative count 6. So fourth position gives you a cumulative count of this element. Place the element at the index calculated. Okay, so place this element 6. Okay, this is a position. Okay, here this is your count. Okay, not actual index number. So for index number, subtract 1 from here. Okay, so because here we have written the count. When we are counting, we will start from the 1. And here we want to write at the index number. So 6 minus 1 is 5. So at the fifth location, write this value. Write the value of original array element. Okay, so यहाँ पे क्या करने का है, जो 4 वैल्यू है फर्स्ट मैच कर दो ये इंडेक्स नंबर से 4 to 4. Then first match this value with this index number and then index. Okay, so at this index, what is the value? 6. But this is your cumulative. See, this is cumulative sum. Okay, so this will indicate you the count. So here we are using this for the index. So 6 minus 1 is 5. So at the fifth location, write the value 4. So 4 is here. Okay, in this way for the 2 also. Okay, take a 2, then compare this 2 with the 2. Okay, then here is a 3, then 3 minus 1 is 2. So add the 2, write the value 2. Okay, in this way you can do it. Okay, to maintain the stability, you can start it from the end of the array. So if here is a 2, 2, what is mean by the maintaining the stability? Suppose there are the 2 times 2 value, then if this is your first value, then put this value before this. Okay, means suppose there are the 2 values R and S. If R is present here before the S in the original array, it is necessary to put this R before the S in your output array. Okay, so maintain the stability. Now let's see the C code for this. Here we require the 4 different for loops for this. Okay, so let's see. Here is your counting sort function array and size. Output array is done. maximum, assign this first element to the maximum and find out the maximum, find the largest element of the array first. Then the size of count must be at least max plus 1. Okay, here we have seen this max plus 1. We are taking this max plus 1. And here this for int I equals to 0, I less than equals to max plus plus I, pre-increment. Okay, all set all the elements to the 0. So count of I equals to 0. Then store the count of each element. Here we are storing the count of each element and we are writing this in an array of I. Okay, here we are using the count array. Okay, but count of array of I. See, in this example here we are using this count of. See, here is count of array of I. Here is this index. Okay, and here is count. How many times this element is occurs inside the this. Okay, means how many times to occurs in this. So that's why we are using this array of I and then plus plus. Increment the position. Then store the cumulative count of each array. So how to find the cumulative count? For the cumulative count, we are adding the count of I plus count of I. Count of I equals to count of I plus count of I minus 1. See, here we are adding the cumulative count. Means this plus this. Means count of this is what? Count of 2 is what? Count of this plus this. So that's why here we are using count of I equals to count of I plus count of I minus 1. Means current element and the previous element sum is this. Okay, for all the elements. Next, find the index of each element of the original array in the count array and place the elements in output array. Okay, find the index of each element in a count array and place this element in correct position in output array. So for this we are doing this array of I. Where to put this array of I? Where to put this 4? Okay, so we are putting this 4 in output array. Okay, we are putting this output of count of array of I minus 1. Okay, we are using see output. This is your output. Here is the location, this count of this array of I, okay, minus 1. So here we are doing the output of first array of I, take this array of I and then count of array of I minus 1. Means see, this is array of count of array of I. This count of array of I is what? See, the array of I is 4. 4th location is 6. 6 minus 1 is 5. So 5 put in this location. So put here and then count of array of I minus minus. Okay. Why this decrement? Because we are decrementing the value. We have started from the end of the array. Okay, to maintain the stability. And then copy all the elements of this array into original array for sorted order. In this way, you can use the counting sort for your problem for your array. Thank you.